Well, I know that everyone is probably at this point just dying to hear Matz's keynote and take a long nap. It's been a fun week. So thank you for showing up for what might be the most boring talk of this entire conference. We're going to talk about sigstore-ruby. Just a little show of hands. Who here has heard of sigstore? I see a couple of hands. Who here has heard of Ruby? You're at RubyKaigi. Come on, you've heard of Ruby. So one of the two parts of this talk will be a bit more familiar than the other. So a little bit about me. I am at Giddins everywhere on the internet. My name is Samuel. I am the Ruby Gems bundler and rubygems.org security lead and a member of those core teams. By day, I am the security engineer in residence at Ruby Central. And also by day, because part of my job, I am the developer, maintainer, and most frequently the debugger of sigstore-ruby. I just want to say, Chag Sameach, if there's anyone else observing Passover this week. I did have to bring my own supply of matzah to Japan. They took up about half of my suitcase. Okay, now on to the meat of this talk. Now, as a disclaimer, everything in this talk is about the learnings I took away from building sigstore-ruby. In no way do I mean this to be a negative talk. I know I sometimes sound negative. It's not intentional. It's just, being a New Yorker. But I want us as a community to take away inspiration on how we can make building this sort of software in Ruby just a little bit easier. So sigstore-ruby is a pure Ruby implementation of sigstore verification and signing. There's a lovely GitHub repo that I'm amazed that 18 people have bothered to star. It is also a Ruby gem, of course, the sigstore-ruby gem. And what's pretty cool about sigstore-ruby is it powers that very bottom section of the gem page on rubygems.org. That little bit that says provenance, built and signed on GitHub Actions, the commit, the build file, the transparency log entry. Yeah, that's the thing that I spent all of last year building just to get that one little bit on this website. So sigstore, for those of you who aren't familiar, it's built to answer the question of where does a gem come from? What commit was it built from? What repo? When was it built? On what CI system? And to answer that question in a way that is cryptographically verifiable. And in the future, all this is going to be used as the basis for policies around what gems to install. So you can say things like, every gem that starts with the prefix AWS, where should that come from? Who should have published it? Probably the folks over at AWS, because they've got 230 of them, and sometimes it's hard to keep them straight. So what is a sigstore client? What is it I spent all this time building? It can be summarized as two functions. Function number one verifies that an artifact and a sigstore bundle match against a trusted root. And function number two is cryptographically signing an artifact against a trusted root. Piece of cake, two functions, no challenges here. Okay, fun talk, I'll see you later. Unfortunately, those two functions are complicated. So getting back into it, taking a step back, what is a sigstore? I will quote from their website, sigstore.dev. Software safety, integrated. A combination of technologies to handle signing, verification, and provenance checks that respect privacy and work at scale. Show of hands if that means anything to you. No? Okay, so we've all been sort of inoculated against marketing speak. Good to see. Being a bit more specific, what is a sigstore? It's composed of a bunch of things. Number one is a TUF, which stands for the Update Framework. It's a TUF repository that serves a trusted root. It is a service that issues signing certificates based on OIDC tokens. Don't forget there's also a certificate transparency log, so you can see what certificates have been issued. There's a service that records stuff in a transparency log. And there's a bundle format that has artifacts from all of the above that you can show to people, and they can do the cryptographic verification thing. Above all, sigstore is a crypto system that we're going to use to build trust for software artifacts. Super serious stuff. So it's important we get it right. Now, I went and I asked our favorite professor, Professor ChatGPT, why is writing a sigstore client from scratch so difficult? Here's the answer. Writing a sigstore client from scratch can be quite difficult for several reasons, primarily due to the complexity of the underlying cryptographic protocols, integration with various services, and handling security concerns. Here's a breakdown of the challenges you might face. I love just getting other people to write my slides for me. There's the complexity of the sigstore protocol. There's the sheer volume of the cryptographic foundations. There's interfacing with all the different services, all the security configurations. I love how that's just a bullet point. We're building a security library. One of the challenges is the security. Give that real helpful. Integration with other tools, API design and usability, testing and debugging. So basically everything about building a sigstore client from scratch is difficult. Thanks, ChatGPT. Makes me feel better. We had a bunch of implementation goals when I set off to build sigstore-ruby. Number one was having a pure Ruby implementation of both signing and verification flows. Number two was being 100% vendorable inside of Ruby Gems and Bundler, because we want to be able to vendor Ruby Gems and Bundler inside of the Ruby distributions, so anything vendored inside of Ruby Gems and Bundler needs to also be vendorable. And biggest implementation goal was don't trust this guy to write any novel cryptography code. Here's a kind of difficult question. What does it mean to be pure Ruby? I came up with a couple of options here. Just let me know when you think I've gotten to a good definition. Well, there's an ISO standard for Ruby. So is pure Ruby something that runs on ISO Ruby? Probably not. I don't think I've seen anyone reference that standard in quite a long time. Is it only Ruby code that's runnable with mini Ruby? Is it Ruby code that only requires the standard library? Or only requires the standard library and bundled gems? And, what about JRuby and Truffle Ruby, running Ruby on WASM, etc.? All of these are kind of reasonable definitions for what it means to be pure Ruby code. And the consensus around the community seems to be, it's the non-end-of-life versions of MRI, and the latest version of JRuby, and the latest version of Truffle Ruby, and using the stuff that's available in all three of them, which is the standard library, default and bundled gems. This is what Ruby Gems targets, this is what Bundler targets, this is what a bunch of the Ruby gemified standard library targets. But writing pure Ruby is still kind of hard. Industry standard libraries, for better or more realistically for worse, are still mostly written in C. They're not written in Ruby. Ruby standard library primitives are largely implemented in native code, not in Ruby. And every layer of wrappers that we deal with leads to sort of an increased impedance mismatch. Trying to write code that digs through like 6 layers of wrapper code means it's hard to sometimes do exactly what you need to do. And finally, when you're supporting older Ruby versions and multiple different implementations of Ruby, well, that means you can take even less for granted. You can only depend on what's in the intersection of all of those different Rubies. So it was suggested for a while that everyone building a sigstore client should just write a wrapper around some Rust libraries. That was going to be the solution. Rust fixes everything, I was told. But, it turns out that wasn't going to work for us. Having a dependency on compiling native code was a no-go for something that needed to be able to ship inside of Ruby Gems. Also, writing Rust code that then deals with both Java and C sounds like a miserable time. We also want the ability to, update sigstore-ruby outside of Ruby releases. So we weren't going to go and stick that Rust wrapper inside of Ruby itself. Not that they would let me do that anyway. And as I said before, support for all of the different platforms that Ruby runs on makes wrapping a single native library a really hard answer. And unfortunately, all that, just rewrite it in Rust and everything will be fixed and the world will be perfect, turned out just to not be the panacea we were promised. So I started on our pure Ruby implementation of a sigstore client, wrote the first line of code last February, shipped the first release in October, and had its first use in production mid-November of last year. That's a lot of time I spent building this one small library. So, Sam, why are you so bad at your job? Why did this take you so long? I heard you all agreeing with that comment. And it turns out that doing an end-to-end sigstore verification flow, it does a lot of stuff. So I'm just going to roll through the list of all the things here, and if you're confused about any of the acronyms, well, yeah, there's just a bunch of acronym soup to learn. So sigstore deals with the update framework, which is a whole specification unto itself. A bunch of different functionality like refreshing tough repositories, downloading targets. We then read a sigstore bundle JSON file and validate the bundle. We have to be able to cryptographically hash artifacts to match them against the bundle, establish a trusted source of time from the bundle and X509 certificates, perform X509 path validation to make sure that the certificates we're verifying actually come from the root of trust that we're expecting, perform signed certificate timestamp validation against those certificates, verify inclusion of log entries in transparency log, verify the certificate against a policy that says, hey, who's supposed to be able to sign for this artifact, verify that the signatures against the artifact and the signing certificate match, and ensure consistency between what's in the payload of the bundle and the policy for the artifacts that we accept and the signing certificate, and make sure all that matches. And, cross your fingers and hope you did all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 steps correctly. And, I'm just a Ruby engineer. It's a lot of plumbing that I was responsible for, in addition to needing to write a lot of these primitives. And unfortunately, the guarantee that all of these pieces work together is the responsibility of the person implementing a sigstore client. And that's me, and that's kind of scary. I don't trust me. So there are a bunch of primitives that are needed to even start thinking about implementing a sigstore client. And they're all things that you probably take for granted, but it's worth enumerating them. So sigstore stuff is defined in terms of Google's protocol buffers. Fortunately, only the JSON encoding of protobufs is used, but that means you need a protobuf implementation. You need support for different cryptographic signing algorithms. Just what's required by the specification is RSA, elliptic curve DSA, and ED25519. You have to support X509 signing certificates, RFC 3161 signed certificate timestamps. I'm pretty sure that RFC is signed certificate timestamps. If anyone knows off the top of their head that I am wrong, congratulations, I'm sorry you know that off the top of your head. There's this signed note format that Go started using for the Go SumDB. There's Merkle trees underpinning all of the public transparency log stuff. There's 2 different JSON canonicalization formats. Because did you know that there exists 2 different JSON canonicalization formats? That's like 2 times as many as there should be. And then there's even more primitives that are needed to sign. So there's all of the stuff from the previous slide. In addition, you have to be able to understand JavaScript web tokens that represent an OpenID Connect identity. You have to generate a key, do more X509 stuff, create one of those signed timestamps, make a signature, and then speak the log entry format that sigstore expects, which is a whole bunch of acronym soup. And sometimes I wish I didn't know it because it's not the tasty kind of soup, And then there's HTTP clients that are needed to talk to 2 of the different services that constitute sigstore. Recore is the transparency log. Fulcio is the certificate issuer. And as I was building all this, I'm like, that is a lot of primitives that you're assuming that every language has available and documented and working properly, and implemented securely. And in the places where that stuff wasn't available or wasn't documented or wasn't working properly, I had to go and implement stuff myself. And as I said, I don't trust me to do that. And also, that's a lot of work that I didn't want to do. So as a reminder, everything I was doing was limited to the Ruby standard library because the goal is to ship a sigstore verifier inside of RubyGems. And RubyGems ships with Ruby and JRuby and Truffle Ruby. So that means no dependencies that can't be vendored, which means plain Ruby code. So what do we have available? We have the OpenSSL gem. That's about it for cryptographic primitives. We have the JSON module. That was everything that the standard library gave me that I needed. So diving in, OpenSSL gem. It is a wrapper around OpenSSL. It supports a bunch of different OpenSSL versions. Up until last year, I think it supported up to all the way back to like OpenSSL 0.9 point something, which is ancient. On some of those supported OpenSSL versions, it didn't have support for ED 25519, which I needed to be able to pass the sigstore conformance test suite. It's missing some functionality that's present inside of OpenSSL. So things like querying about certificate properties. There's the fact that extension OIDs and short names get mixed up. So being confident about what X509 extensions you're talking about is a little difficult. Pulling out the to-be-signed pre-certificate bytes from a certificate wasn't implemented until I sent a pull request, and even then, because we support all the way back to Ruby 3.2, I had to re-implement that in pure Ruby as well. Was missing signed certificate timestamp validation, which again, had to just re-implement in pure Ruby, and was also missing RFC 3161 validation at my choice of timestamp. It would only validate against the current time, which is not what sigstore needs. Now, believe it or not, this is the better version of the OpenSSL gem. There's also JRuby OpenSSL. And not a knock on the JRuby team. Writing a Java-based wrapper around a Java library that tries to mimic the OpenSSL API is a challenge, and I wouldn't want to do that. So kudos to them for doing it, but it's missing even more stuff. So JRuby OpenSSL is a bouncy castle-based implementation of the OpenSSL API. There is a long-standing bug where you can't do X509 path validation against a certificate chain that has intermediary certificate authorities. It's missing ED 25519 support entirely. It's missing, or it was missing, I have to give them credit, they did implement this a few months ago, public key dir export support. And it's also missing everything else that's missing from the CRuby gem. Now, it was so difficult to get some of the stuff working on JRuby that I had to reach down into the raw java.security APIs to have support for all the primitives I needed. So here's a fun commit that I landed last December, where I re-implemented all the missing JRuby functionality just using, just in this room we were talking about how in JRuby one of the great things is you can just use Java classes and Java methods. I had to do that to get sigstore-ruby working on JRuby. And it was a whole bunch of changes. And if you look at those changes, they're pretty gnarly. So inside of sigstore-ruby itself, we also implemented an X509 wrapper to allow querying certificate properties and typed extension values, implemented RFC 8785 JSON canonicalization. As I said, there's multiple JSON canonicalizations. This is one of them. Implemented by manually shifting around the ASN1 bytes of X509 certificates, grabbing out the to-be-signed pre-certificate during coding. Everything with signed certificate timestamps also had to be implemented outside of OpenSSL. RFC 3161 support. Support for DESI, which is something simple, dead simple security envelopes, I think is what DESI stand for. Not that dead simple. I had to implement an entire tough client, and it was tough to do that. And inside of tough is where I got to implement the second JSON canonicalization scheme. How did this all get so complicated? We started by saying we're implementing 2 functions. This is a lot of stuff for 2 functions. And it happened because Sigstore is the amalgamation of multiple different systems. It uses X509 for PKI, Tough for a trusted material distribution, Merkle trees for transparency log inclusion, and sign notes for checkpoints. All of these have libraries in some ecosystems. If you write Go, you can import the X509 library. You can import the Tough client. You can import the Merkle tree library. You can import the sign note library from Go's module system. All of that's there. But not all of these things are there for Ruby, and they're certainly not all in the standard library. And even X509, which is difficult to work with. Additionally, all these things have multiple different configuration points, different switches you can flip, and that leads to a combinatorial explosion of the configuration space. Different key types, signature schemes, 2 ways of encoding the contents of Sigstore bundles, different DESI payload types, different in toto statement types. That's just a lot of different stuff to implement. And the point of building all this wasn't even just to build the client, it was to integrate it into RubyGems and rubygems.org. The good news is, this was not the first Sigstore client, it was one of many, and re-implementing these things helps mitigate the impact of a bug found in any one implementation. Re-implementing this stuff over and over helps make the Sigstore specification more precise and more portable. Each new implementation, including Sigstore Ruby, hit different edge cases. Each implementation provides a different way of thinking about the specification we're trying to implement. Luckily, everything I was doing got a little bit better in 2024. We got multiple conformance test suites, so I didn't have to go and write my own tests. There was a wonderfully edited Sigstore client doc that I could go down and use as a checklist. There was convergence between different implementations. There's a mock Sigstore implementation, and my buddy William Woodruff just helped me a ton. And so, we talked a bit about building Sigstore clients from scratch. The good news is the next client someone builds will be easier. The Sigstore community has gone from prototyping to early adopters to now being sort of a critical and well-used production system. Building Sigstore Ruby last year was challenging, and I really hope that the next person building a Sigstore client has an easier time. So come say hi if you want to talk about or contribute to Sigstore Ruby. Come say hi if you want to make implementing Sigstore Ruby a little bit easier in Ruby. And thank you.